Hello everybody, this is Mr. Bowman. Today we're going to be looking at the ALEKS topic, relationship between the sines and cosines of complementary angles. So we're going to look at our right angle here, because that's how we get a complementary angle. Remember, they have to add up to 90, so if I look at these two, they have to add up to 90, so the whole thing adds up to 180. Okay. So they give me angles of capital A, B, and C, side lengths of lowercase a, b, and c, and I'm going to use those to start filling some stuff in. So looking at A as my first perspective here for the first two, I want sine, which is opposite over hypotenuse, so A over C, and then cosines adjacent over hypotenuse, so B over C. Now, I'm going to change perspective here a little bit. Now, this B is my reference angle, so that's adjacent to A, and B is opposite. C is still the hypotenuse, that doesn't change. But your adjacent and opposites do flip-flop. So side B is adjacent to A, but side A is adjacent to B, so they kind of change because we're in a different location. So here, sine is still opposite over hypotenuse, but the opposite of B is side B. So that's B over C. And cosine adjacent would be A over C. Okay. So in triangle ABC, angle A and angle B are complementary because they have to add up to 90. Okay. So select all the true statements. Is sine A equal to sine B? No. False. Sine A cosine B is true. Cosine A is equal to cosine of B is false. BC, AC. Cosine of A is equal to sine of B is true. BC and BC. None of the above. Okay, well that's false because two of them are true. Okay. So using that logic then, if I go down here to the bottom, what does sine of 77 degrees have to be equal to if I know it's a cosine of something? So if looking up here, my sine of A has to be equal to the cosine of B, which is its complementary angle. So what would I add to 77 to get 90? Well, that would be 13, right? So 77 plus 13. So this would be 13 degrees. So sine of 77 degrees should be equal to cosine of 13 degrees by this logic.